let's get into my first example here. Next one. For example, here's my differential equation that I'm trying to solve. I have x double prime plus 4x prime plus 6x equals 8 delta sub 2 pi of t. X naught is 3 and x naught prime is 2. So this is very much going to be an example with everything in the kitchen sink going on. X double prime plus 4x prime plus 6x equals 8 delta sub 2 of t. X naught is 3 and x naught prime is 2. So quick physical application before we jump into solving this problem. This is modeling the object motion on a spring, right? It is damped motion because there is a 4 over here. My spring constant is 6. And then we've got a force, a shove, with magnitude of 8 at time t equals 2 pi. So remember, the right-hand side is your external force. It happens at time t equals 2 pi. It has a magnitude of 8. You know, my initial position is stretch 3, and it's stretched instead of compressed because it's positive. My initial velocity is 2 whatever units per time to the right. Because it's positive, it's going to be to the right. Okay, so that's your physical, just a quick reminder back from chapter 2, physical interpretation of what is going on here. Okay, do the first step. We got 3 steps in solving these differential equations. You should be good at the first step by now. Do the first step of taking the Laplace transforms and the second step of solving for capital X of S. You should be able to do both of those. Double check my work on my whiteboard also once you get this far. Got a thumbs up from somebody. I'll keep working here. Got a couple of thumbs up, that's good. No rush, we've got time. That's nodding, good. I didn't make any stupid arithmetic mistakes, always a good thing. People are nodding at me. Okay, so here's what we got. Capital X of S is 3s plus 14 plus 8e to the negative 2 pi s over s squared plus 4s plus 6. Denominator does not factor. Denominator does not factor, so we are going to need to complete the square because that does not factor. So if we complete the square, this is going to be, I'm going to break it up into pieces also. 3s over s plus 2 quantity squared plus 2. You can write the details out of completing the square. We would need a plus 4 in order to complete the square, and that would leave us with a plus 2 left over here. So that's where the plus 2 and the other plus 2 come from. Plus 14 over s plus 2, quantity squared plus 2, plus 8 e to the negative 2 pi s over s plus 2, quantity squared plus 2. So completing the square, and breaking it up into 3 separate pieces, completing the square and breaking it up into 3 separate pieces. Okay, all of these pieces have an s plus 2. So other than this last one with the e to the negative 2 pi s, because that just multiplies, I need an s plus 2 in all my other places where I have an s. So this first one needs to turn into 3 times s plus 2. I can't just have an s, I need to have an s plus 2. I'm gonna have to fix that in just a minute, but let's leave it there. So then we've got s plus 2 squared plus 2. Okay, so I just added 6. That means I also need to subtract 6 in order to fix that. I just added 6, so I also have to subtract 6. This next piece is totally fine. There's no other s's. 14 over s plus 2 squared plus 2. And then let's pull that e to the negative 2 pi s out in front. So we've got 8 over s plus 2 squared plus 2. We'll just write that e to the negative 2 pi s out in front. Okay, this minus 6, I want to actually group together with the second piece. So we want to take that minus 6 and the 14, the denominators are the same, so we're going to group those together in the second piece. They're going to work a little bit better there. We've got 3 pieces now. We'll label them pieces number 1, 2, and 3. And piece number 2 is going to have an 8 in the numerator. Do we see why piece number 2 is going to have an 8 in the numerator if I group those 2 together? Okay. All right, do the inverse transforms for piece number 1 and piece number 2 for me. Those should be relatively straightforward, front of the book. Inverse Laplace transforms for piece number 1 and piece number 2. Do both of those for me. I'll leave this up for just a second, then I'll switch my whiteboard. So you're gonna need your book. Piece number 1, piece number 2. Do the inverse transforms for both of those. Maybe we'll see if we can fit it on the same whiteboard. Piece number 1 should be a cosine, and then piece number 2 should be a sine. And because piece number 2 is a sine, you're gonna need to mess with your coefficients on the top a little bit. So you're gonna need to do a little bit of messing with coefficients on the top for piece number 2. Okay, for piece number 1, I get 3e to the negative 2t cosine square root of 2t. Are we good on that one? Give me a thumbs up there. Thumbs up on that one. Yes, good. Okay, cool. Second piece, I got to mess with the coefficients. I need a square root of 2 on the top, so I have to divide by square root of 2. So 8 divided by square root of 2. E to the negative 2t sine square root of 2t. We're good on piece number 2. We like that one. Yes, happy? Okay, cool. For piece number 3, I've got this function inside. So let's call that capital F of s. That's going to be 8 over s plus 2 quantity squared plus 2. That's the piece on the inside that's being multiplied by the e. So we just did this one actually. It turned out to be the same. Little f of t is then 8 over square root of 2 e to the negative 2t sine square root of 2t. That's the piece inside that's being multiplied by e to the negative 2 pi s. So then, because I have an e to the negative 2 pi s out in front, that means I need my unit step function. So piece number 3, u of t minus 2 pi, and then I have to plug in a t minus 2 pi wherever I see a t. So we've got times 8 over square root of 2, e to the negative 2, t minus 2 pi, sine of square root of 2, t minus 2 pi. That's what that e to the negative 2 pi s does out in front. It gives you a unit step function, and it plugs in t minus 2 pi everywhere you see a t. And then my final answer, I'm not going to rewrite all of these, but my final answer for little x of t is 1 plus 2 plus 3. As long as everything's clearly labeled, you can do that on your test too. That is fine. So my little x of t is going to be those 3 pieces added together. One thing to note, I do not, this is a sine of t minus 2 pi. So you might think, oh, that's periodic, and I can just do a sine of t. Does not work because we've got this square root of 2 out in front. So the square root of 2 messes with the periodic nature of this, and therefore you can't necessarily just get rid of this t minus 2 pi. So don't worry about simplifying it. I'm not going to make you simplify it or anything like that, but just know that in this example, you might not be able to because we've got that square root of 2 out in front. Okay, again, this is like the last example that we did yesterday. This is my everything in the kitchen sink example. How are we doing with my everything in the kitchen sink example? Doing good? Making sense? Yes? Good. Questions on this example before I clear my whiteboard and do one more? And when I say I do one more, I mean you do one more. Anything? Okay, one more then. This is the other one that I want to do today. Here's your example. For example, 2x double prime plus x prime plus 2x equals delta of t minus 5. I'm just switching up notation to get you comfortable with both. That's the same thing as delta sub 5 of t. So 2x double prime plus x prime plus 2x equals delta of t minus 5. I'll be nice to you. X naught and x naught prime are both 0. 2x double prime plus x prime plus 2x equals delta of t minus 5. X naught and x naught prime are both 0. So think about what's going. Mass of an object. This is an object moving back and forth on a spring. There is no initial velocity, correct? The initial velocity is equal to 0. The initial position is equal to 0. So the object starts at equilibrium, neither stretched nor compressed, and it doesn't move until it gets a shove at time t equals 5. So this object does not move until time t equals 5, and then it gets a shove of magnitude 1. That's what's going on here. Okay, initial velocity is 0, initial position is 0. Okay, I'm going to stop sharing my screen and divide you into breakout rooms and have you work through this one. You should get square roots in your answer. If you get square roots in your answer, that is perfectly acceptable. It's a good thing in this case, all right? We are randomly dividing you into breakout rooms. There you go. They should be open. I'm going to stay here and write on the whiteboard, and then I'll pop in.